Okay, in question 6, it gives you these ionic compounds, and it says the student learns that ionic compounds have significant covalent character when a cation has a polarizing effect on a large anion. As a result, the student hypothesizes that salts composed of small cations and large anions should have relatively low melting points. Select 2 compounds from the table and explain how the data support this student's hypothesis. So to answer this question, we need to choose 2 compounds that either have the same anion or have the same cation. So for example, I'm going to just start off with the first one. I'm going to do lithium iodide and potassium iodide. Now, since lithium iodide has a smaller cation than potassium, the melting point of lithium is going to be lower than that of potassium because it has a smaller cation, right? Even though they both have a large anion. So that supports the hypothesis that small cation and large anion cause a low melting point. You could also look at, for example, lithium iodide and lithium fluoride, comparing the sizes of those anions. So since iodide is going to be larger than fluoride, that means lithium iodide should have a lower melting point, which it does. So all of those work perfectly fine. Okay? In B, it says identify a compound from the table that can be dissolved in water to produce a basic solution. Write the net ionic equation for the reaction that occurs to cause the solution to be basic. So remember, looking at those 4 salts, I need an anion. And I need an anion that came from a weak acid. So the only one that's there, hydroiodic acid, is strong, so that doesn't work. So either LiF or NaF. So it doesn't really matter because we're going to ignore the Li and the Na. So the reaction would be F minus plus H2O, and that's going to produce HF and OH minus. So you can choose either LiF or NaF, it doesn't matter, but then you need to write the correct reaction. So you got 1 point for choosing the correct compound and 1 point for writing the correct balanced reaction. Okay, because you're showing F minus taking the proton from water, therefore it is the base.